Hey guys, welcome back to our channel. This is Remy from Do and Learn. Today we are going to learn about complement of numbers. So let's get started. So what do we mean by complement of numbers? Actually, complements are a representation of numbers in either binary form or whatever number system we do follow. So complements are used in digital computers just to simplify the subtraction operation or for other logical manipulation. So if we represent numbers in the form of complements, then that will ease our process during some of the arithmetic operations like subtraction. So moving forward, so what is the need for simplifying certain digital circuits? So when we try to simplify certain circuits, obviously number of hardwares what we use related to the circuit gets reduced. And once you reduce the number of hardware components in a circuit, obviously the circuit becomes less expensive and also it's pretty much simpler. But at the end of the day, the output is same and also the efficiency increases. So in order to do this, complements might be of help to us. So ultimately, there are two different type of components for every base system, or base is also called as radix in any number system. So the two types of complements here, one is radix complement, which is commonly referred as R's complement, and the second one is diminished radix complement, which is also called as R minus 1's complement. Here, the variable R refers radix. And it is also called as base of any number system. So internally, base and radix are almost same. So in binary system, we have the R value as 2, so it's 2's complement, and R minus 1 is 2 minus 1, that is 1's complement. Whereas when we go for decimal number system, it is 10's complement and 9's complement. So let's get started and let's try to understand how we are supposed to calculate these complements. So we will start with diminished radix complement. So diminished radix complement is commonly called as R minus 1's complement, and it can be calculated with the help of a small formula which is given by R power n minus 1 minus n. So here we have three different variables. One is R, which represents the base of that system, and second one is small n, which represents the number of bits inside the number for which we are going to find the complement, and this capital N represents the number itself. Okay, we will try to solve this with the help of a small example. So let's try to get the 9's complement of 56236. 56236 is a decimal number. So if I want to get the 9's complement of this decimal number, I have one option. What I can do is, since it is 9's complement, R value is 10, and you know that R minus 1 gives you 9. So we are supposed to find 9's complement, so we take R value as 10. So according to this formula, what we have here, it is R power n minus 1 minus n. So R's value is 10. And this small n represents the number of bits inside the number for which we have to find the complement. And according to our example, we have 1, 2, 3, 4, 5 bits. So this is 10 power 5 minus 1 minus n represents the whole number, that is 56236. So that's what we have here in this calculation. So 10 power 5 minus 1 minus 56236, that gives me 10 followed by 5 zeros minus 1 minus 56236, and ultimately you will be getting 5 9's minus 56236, and 43763 is the final answer. There's another shortcut to this. Instead of directly evaluating your expression with the help of this formula, if suppose you are asked to find out 9's complement of any number, you just write the number and subtract each and every bit of that number from 9. So ultimately you will get 9's complement. So that's what we are going to do here. 9 minus 6, that gives me 3, 6, 7, 3 and 4, and that's the final answer. So hope it's understood. We'll move to the next one. So the next type of complement what we are going to see here is radix complement. So radix complement R is given by formula R power n minus n. As usual, R means the same, which is the base of the number system. Small n means the number of bits that are present inside the number for which we are trying to find the complement, and capital N is the number for which we are trying to find the complement. So for example, we can take the same number as previous. So 56236, we are going to find the 10's complement. So our direct question is to find the r's complement of 56236. So it's pretty simple. You directly apply that formula. So according to the formula, it's r power n minus n. So that gives me r's value is 10. 10 power n. N is actually 5 here. So 10 power 5 minus capital N is the same number, 56236. So it's 1 followed by 5 zeros minus 56236. So you will get the answer. And that's what we have here, 43764. Hope it's understood. Now, can we find a relationship between these two complements version? One is Radix complement, which is commonly called as r's complement, and another one is diminished Radix complement, which is r minus 1's complement. So if there is a possibility to find the relationship between these two, we can write r minus 1's complement with the formula r power n minus 1 minus n. Let's say we are trying to add 1 along with this. So on my right hand side, I have 1 added. Now if I expand this, that gives me r power n minus 1 minus n plus 1. So mathematically, I can cancel these two ones. So the final answer is r power n minus n, which is nothing else but r's complement of any number. So we can find a common relationship between this diminished Radix complement and the Radix complement, and the final decision is r's complement is equal to r minus 1's complement plus 1. So that's the ultimate understanding from this conclusion. So we have learned two different complements. One is Radix complement and second one is diminished Radix complement and the relationship between them. And also we have found out how to find the complement, 10's complement and 9's complement of a number. We have certain examples here. Let's try to solve this. So let's take the first one. They're asking us to find the 9's complement of 26588. So what we can do is, I'll have 5 9's because I have 5 bits here. So that is 26588. So that will give me 9 minus 8, 1, 1, 4, 3 and 7. So similarly, you can find 10's complement of 5698. Since we know that r minus 1's complement plus 1 will give us r's complement. So if I want to find 10's complement, I can just find 9's complement and add 1 along with it. So that will give me an answer. So let's try that with this example. So we have 5698. So I'll try to find the 9's complement of 5698. 5698. So that is 1, 0, 3 and 4. You add 1 along with it so that you will get 10's complement. So this is same as the previous case what we have seen. Now we can try to solve 2's complement and 1's complement of binary numbers. So let me take a fresh page and let me write one number, 11010. So this is the given number and they're asking me to find 1's complement of this number. So 1's complement of a binary number can be found out by changing all 1's into zeros and all zeros into 1. So that will give us 1's complement. So if you want to find out 1's complement of this number, that gives you 0, 0, 1, 0 and 1. So I have changed all zeros into 1's and all 1's into zeros. So similarly, if you want to find 2's complement of a binary number, you already know that r minus 1's complement is plus 1 gives you r's complement. So 2's complement can be easily found out by getting 1's complement and adding 1 along with it. So let's take a small example, 1110. So let's try to find 2's complement of this number. So if you want to find the 2's complement of this number, first try to find out the 1's complement, which is 0, 0, 0, 1 and add 1 along with it. You will get 1 plus 1 is 0 and I carry 1 forward. So this is binary system. So 2's complement of this number is 0, 0, 1, 0. Let's try to solve another example, but this time we will try to have a fractional number with it. So let's say we have 237.86 and they want us to find the 9's complement of this number. Or let's take like they want us to find the 10's complement of this number. So what we do, we find 9's complement first, then we add 1 along with it. So finally we get 10's complement. So let's start with 9's complement. I have 5 bits. I will just distribute that number irrespective of whether it's a fractional number or a whole number. Don't worry about that now. So it's 9 minus 6, that gives me 3, and this is 1, this is 2, and this gives us 6, and this is 7. Now in order to find the 10's complement, we have to add 1. But please be careful in this point. Adding 1 doesn't mean we are going to add that with the mantissa part here. Instead, 1 is always added to the least significant bit of any number. So here the least significant bit is this. I will be adding 1 here. So you will get 3 plus 1, that gives you 4. And this is 1.267. So hope it is clear. So in a similar fashion, if you want to find 2's complement of any fractional binary number, let's take it like 110.11, and you want to find the 2's complement of this number. So initially we will find 1's complement, which is nothing else but 001.00. You want to add 1, we are not supposed to add 1 here in this place. Instead we will be adding at the least significant bit, that is over here. So 2's complement of this number will be 001.01, or you can simply call it as 1.01, which is again a binary number. So hope it's clear. What we have done till now is we have learned what is a complement of a number and what's the need for it. Then we went on to the 2 different types of complement. One is R's complement, which is Radix complement. Second one is Diminished Radix complement, or R minus 1's complement. Then we found out the relationship between them, saying that R's complement can be obtained by finding R minus 1's complement and adding 1 along with it. And we have found out the truthfulness of that relationship with the help of certain examples. Thank you.